This is a extra review of some of the material in Chapter 3. Chapter 3 is where we really started getting into calculations more, so I wanted to do a little more review of problems. Also notice that I have a very Halloween theme to this because I enjoy Halloween, and I was in a Halloween mood when I made this. So for the first slide here, we're going to be using the empirical rule, which is that whole making the curve and the percentages, 68%, 95%, all that fun stuff. So vampires prefer human blood based off platelet count with a bell-shaped distribution. So I'm going to draw this out. You're going to draw lots of normal curves throughout this class. Mean platelet count is 280. That goes right down the middle. With standard deviation of 65. So remember, I go 3 standard deviations out when I'm using the empirical rule. So I'm going to try to somewhat evenly space these. 3 to the left, 3 to the right. And now for each one of these marks, that's going to be adding 65, adding 65, adding 65. And subtracting 65, subtracting, subtracting. So if you run those numbers real quick, going to the right, I'm going to get 345, 410, and 475. If I go to the left, again, this is subtracting 65 each time, 215, 150, and 85. So for part A, what percentage of victims have platelet counts between 150 and 410? Well, 150 is 2 standard deviations low, 410 is 2 standard deviations high. That, according to the empirical rule, represents 95% of the data. For letter B, between 215 and 345, well, that's only 1 standard deviation each way. That, according to the empirical rule, is 68% of your data. For letter C, what range encompasses 99.7%? That's going out 3 standard deviations. So 3 standard deviations each way. That means that's going to be from 85 to 475. And for letter D, would a victim with 140 be considered usual or unusual? Well, 140 would lie right around here. Remember, it's 2 each way. That's my cutoff for usual values. So this is outside of that range, so this would be unusual. For our next slide, we're looking at percentiles. So now we've got zombies killed by headshot in Illinois cities. So they are sorted, so that's good because we need that for percentiles. Part A, find the percentiles for the following numbers of headshots. So remember, to find the percentile, we take the number of values smaller than it, divide by the total number of values, and then times it by 100. And it says on here, we're going to round to the nearest percentage. So for 213, I count how many values are below that, which is 3. Divide by the total number, which there's 6, 12, 18, 24 values. I multiply that by 100. And we're going to round to the nearest. So if you round it to the nearest percentage, it's P13. So 213 is P13. For 240, oops, don't want that. So for 240, oh, come on now. There we go. 240, we go to 240. We count the number of values below it, which is 8 over 24, times that by 100. We're going to round to the nearest, that would be P33. So 240 headshots represented P33. For 250, now notice that 250 is in there more than once. We go to the first time I see it. And if I count below that, there's 12. That will give me 50. So percentile 50 is 250. And for the last one, if you go to 260 and you count how many are below that, it is 6, 12, 18, 19, 20 over 24. And if you round that, you get P83. For the second letter A, because I messed it up, now we're figuring out the value that corresponds to the percentile. So we're going backwards. So this is going to be using that L over 100, excuse me, K over 100. L is K over 100, and then multiplied by your number of values. So for P60, that's going to be 60 over 100 times 24. That gives me 14.4. Now remember, that's not the answer to the problem. Using that flow chart that we talked about, that's not a whole number, so I take it up to the next whole number, 15. And that means I'm going to count to the 15th value. So the 15th value, 6, 12, 13, 14, 15th. That's the 15th value. So P60 is 251 headshots. And again, the logic behind this is at least 60% of the data is below 251. For P40, 40 over 100 times 24. That would give me 9.6. Again, not a whole number, so I take it up to the nearest whole number, which is 10. So I'm going to count to the 10th value. The 10th value is 243. So P40 is 243. For letter B, find the quartiles, Q1 and Q2. So remember, Q1 is really percentile 25. So I'm going to do the same stuff. But again, I converted Q1 to 25%. So if I run that, that gives me 6. That means I go between the 6th and 7th value. Remember, if we get a whole number on this, we go between two numbers. So the 6th value is 234. 7th value is 235, so I go in between those two, and that would be 234.5. So Q1, which is percentile 25, is 234.5. And for the next one, Q2, that's the 50th percentile. I calculate that, that gives me 12. Again, that's a whole number, so I go between the 12th and the 13th value. The 12th value is 245, the 13th value is 250. I go halfway in between those. If I average those, I get 247.5. And again, that's Q2. Now, you might have noticed that we calculated 250 when we were doing the first part of this. We calculated that to be percentile 50, which would be the median. But here I just said that is 247.5. This is a little bit of a problem with the percentile calculation, but they both mean the same thing. Over here on the right side, 250, I'm saying that 50% of the data values lie below 250. Over here, I'm saying 50% of the data values lie below 247.5. Well, looking at the data, that's true either way. So while the value it calculates is slightly different, it represents the same thing. Our next problem, we deal with some pirates. We've got pirates that stole gold coins. And if you count, I've got 4, 2, 5, 8, and 6. We want the variance and standard deviation, the sample variance and standard deviation. Okay, this goes to where I first have to calculate the mean. So if I add those all up, 4 plus 2 plus 5 plus 8 plus 6, you'll get 25. Divide by 5, so my mean is 5. Now, if you remember, we made a little chart, at least for the first part of the standard deviation calculation. So each x subtracted, or then subtract off the mean. So I'll start with 4 minus 5. So 4 minus 5 would be -1. 2 minus 5, I'm going to the next data value, would be -3. 5 minus 5, 0. 8 minus 5, 3. 6 minus 5, 1. The next step in the standard deviation calculation is to square each one of those. So -1 squared is 1, -3 squared is 9, 0, 9, 1. The next step in standard deviation calculation was to sum those up. So if I add those up, that's going to give me 20. That was this part of the calculation, the sum of each value subtract the mean squared. Now, it does say on this problem the sample, so that means I'm going to divide by n minus 1. There were 1, 2, 3, 4, 5 data values. So 5 minus 1, I'm dividing by 4. So that's going to give me 5. And the last step, oh, by the way, sorry, that is the variance then, if you remember. So the variance, which is called s squared, is 5. which then means the standard deviation is the square root of 5, which is about 2.2-ish. And again, one time on the exam, you'll have to actually by hand calculate a standard deviation. Same kind of idea as what we just did here. For the last problem, we're going to use that standard deviation that we just calculated. What is the z-score for the pirate that stole 6 coins? Okay, so we'll start with that one. For 6-coin pirate, his z-score is for the 6-coin person. His z-score, remember, you do the value minus the mean and divide by the standard deviation. So the value is 6 coins. I subtract off the mean, which was 5 coins, and I divide by the standard deviation, which is 2.2. I just calculated that. So that would give me 1 divided by 2.2, which I'll round to 2 decimals, gives me 0.45 for a z-score. So what is this saying? This is saying that the pirate that stole 6 coins, so here's the middle, and here's 1 standard deviation over. The pirate that stole 6 coins would land about half of 1 standard deviation. Not quite, 0.45 of a standard deviation. He would land a little bit above the mean. And for the last one, the pirate that stole 5 coins, well, you shouldn't even have to do the calculation, but if we run it, 5 minus 5 divided by 2.2, well, that's going to be 0 for a z-score. And if you think about it, what does z-score mean? It means how far are you from the mean? Well, 5 is the mean, so it's no distance away. All right, that does it for this little review of some of the calculation stuff from chapter 3.